of a dark cavern. Behind the prisoners lies a flame, and between the flame and prisoners parade objects that cast shadows onto a wall in the prisoners' field of view. These two-dimensional shadows are the only things that the prisoners have ever seen, their only reality. Their shackles have prevented them from perceiving the true world, a realm with one additional dimension to the world that they know, a dimension rich with complexity and, unbeknownst to the prisoners, capable of explaining all that they see. Plato was on to something. We may all be living in a giant cosmic cave created in the very first moments of existence. In the standard telling, the universe came into being during a big bang that started from an infinitely dense point. But according to recent calculations that we have carried out, we may be able to track the start of the universe back to an era before the Big Bang, an era with an additional dimension of space. This proto-universe may have left visible traces that upcoming astronomical observations could uncover. The universe appears to us to exist in 3 dimensions of space and 1 of time, a geometry that we will refer to as the 3-dimensional universe. In our scenario, this 3-dimensional universe is merely the shadow of a world that has 4 spatial dimensions. Specifically, our entire universe came into being during a stellar implosion in this supra-universe, an implosion that created a 3-dimensional shell around a 4-dimensional black hole. Our universe is that shell. Why would we postulate something that sounds, on the face of it, so absurd? We have 2 reasons. First, our ideas are not idle speculation. They are firmly grounded in the mathematics that describe space and time. Over the past couple of decades, physicists have developed a rich theory of holography, a set of mathematical tools that allows them to translate descriptions of events in one dimension to the physics of a different dimension. For example, researchers can solve relatively straightforward equations of fluid dynamics in 2 dimensions and use those solutions to understand what is going on in a much more complicated system. For example, the dynamics of a 3-dimensional black hole. Mathematically, the 2 descriptions are interchangeable. The fluid serves as a perfect analog for the extraordinary black hole. The success of holography has convinced many scientists that more is at work here than a simple mathematical transformation. Perhaps the boundaries between dimensions are less stable than we thought. Perhaps the rules of the cosmos are written in another set of dimensions and translated into the 3 we perceive. Perhaps, like Plato's prisoners, our personal circumstances have tricked us into believing the world is 3-dimensional, when in fact a deeper understanding of what we perceive will come only when we look for explanations in the 4th dimension. There is a second reason that our 4-dimensional universe is worth thinking about. A close study of this universe could help us understand deep questions about the origin and nature of the cosmos. Consider, for example, the Big Bang, the primordial flash that brought our universe into existence. Modern cosmology holds that the Big Bang was immediately followed by inflation, a period of rapid expansion of space in which the early universe increased its volume by a factor of 10 to the 78th power or more. Yet this expansion provides no insight into what caused the Big Bang. Our 4-dimensional universe, in contrast, gives us an answer to the ultimate mystery: where did the universe come from? The known and unknown cosmos. Our investigations into the 4-dimensional universe came about because of the problems that we have had contemplating the 3-dimensional one. Modern cosmology has been fantastically successful, but its successes belie deep and complex mysteries that may lend themselves to a holographic explanation. Cosmologists can describe the history of the entire universe from the present day all the way back to a fraction of a second after the Big Bang, using only a few equations, chief among them